Hi, and welcome to another episode of Partner Buzz, the AWS partner-focused podcast for business and technical leaders in our APN community. My name is Richard Wilmot, and in addition to being your host for today, I'm a partner solutions architect here in Sydney, Australia. And today I'm joined by Ramya Sundararajan, and we're going to be talking about extreme resilience, because Ramya joins us from the AWS Health service team. Welcome to us today.
Hello.
So just for some clarity, what exactly is AWS Health? Because AWS Health has nothing to do with healthcare.
That's right. So AWS Health is a service where we inform to customers whenever there is an incident happening on any of our AWS services.
Okay.
We do provide visibility into performances of the resources in case they are impacted by that particular incident.
So AWS Health is really one of our most critical services because ultimately our customers need to know that information possibly at the most critical time.
That's right.
Awesome. So obviously, we build our AWS services for the most exacting requirements for our customers, and something like AWS Health is obviously one of the most critical services. What does resilience and high availability mean to you and the team, Ramya?
So there are different kinds of applications, if you really think about, and those that need to be really highly resilient are what we call as the high availability systems. So when you talk about high availability, the most critical thing there is to deal with errors and failovers and have backup so that your service is always functional and available when the customers need to use it.
Right.
When the users need to use it and when the customers need to hear about it. And AWS Health is a classic example. If you really think about the AWS Service Health dashboard, that dashboard tells external customers exactly about the incidents, right? They need to know it on time, and we value that a lot.
Yeah.
So whenever we design for a system such as that, we always have to make sure that it is always functional, always highly available, and extremely resilient. There are some use cases where, latency requirements come into picture.
Yeah.
Again, that totally depends on the application. For example, banking transactions and things, they have to be within that latency requirements. So it really depends on the requirements, but that's, to me, what high availability means.
Interesting. So there's no one-size-fits-all answer when we come to talking about high availability. It really depends on what the actual customer requirement for the workload is. And I know that when we were preparing for the show, you spoke about how your personal mental model is to kind of think about you've got Tier 1 and Tier 2 applications where potentially, Tier 2 might be batch processing, Tier 1 might be that real time, but ultimately it kind of comes down to what the actual needs of those customers are for any given use case, as opposed to just being a simple binary decision.
Absolutely. So on a day-to-day basis, we've had to deal with both highly resilient systems such as Tier 1 systems and the Tier 2 systems such as batch processing and things. They have varied requirements. Again, it totally depends on the application that you're working on. But the design process for when you're designing for a Tier 1 service is entirely different from the use cases that you consider when you design for a Tier 2 service.
Yeah, because ultimately part of high availability is understanding what are those specific risks that you're addressing based on what those customer SLAs need to be. Nice.
Definitely.
Excellent. So really, I think what can be helpful is to think about high availability more of a continuum. So you've got the high probability, low impact events on one side, and then you've got very, very low probability but critical impact events on the other. And really, it's about where the SLAs for that particular workload fit on that continuum. So I think, what are some of those challenges which are maybe more frequent, lower impact, but are still going to be impacting customer outages? I think you spoke about things like, accidental, code changes that might be running through, which could impact customer availability. Talk us through some of that.
That's where, observability becomes key. You need to be notified. You need to be in a position where you're able to quickly fix the problem in the production system and make it available so that the users can actually use it. It really comes to these highly available systems. Some of the key things that we think about are, how do we manage failovers?
Yeah.
We do perform game days to ensure that we know what should be done when those failovers happen.
Yeah.
We cannot just wait for the failovers to happen when it happens and then I try something and it doesn't work. And that's not the time I should be notified of the problem. So we do perform game days to make ourselves more familiar and comfortable with the process. And we also, during design time, think about how can we make sure that if one region has an impact on one of the services and the application goes down on that region, how can another region act as a substitute? So how do you do failover in an active, passive modes and so on? So we've had use cases where, if the downstream operations are all idempotent, then one of the solutions that we do normally is we make parallel calls and the first write wins. So essentially what we care about is the message has to go out. And if I can just get one among the many, I win.
Then you've got success.
So,
I was about to say that's something which I'd love to dig into a little bit more detail later, but I think just winding back a little bit, what you've described is really quite interesting because not all of those risks to your resilience are necessarily going to be architectural. And I think from some of the partners I speak to, we're very laser focused on architectural risk, which I think is obviously critical, but it is one of those less frequent things, whereas I think you mentioned that observability piece and having things like really good DevOps hygiene can help you ensure that you're not actually putting those issues into production already. And I think when we spoke previously, you mentioned that there's a very strong understanding within your team how your workload isn't just that final architecture, it's actually all of the operational processes and the deployment mechanism to make sure that what you're actually deploying is correct. Because fundamentally, if you've got a transaction processing system or a critical notification system, it has to work every single time. And those high probability risks need to be addressed as well. Take us through how you view the CI/CD process as being a critical part of that resilience.
Sure. One of the common mistakes I've seen a lot of people do is do the functionality first and then implement the tests later.
Okay.
Keep the alarms and metrics for the later. And then when it comes to the time of launch, we're all going by deadlines, right? When it comes to the time of the launch, we are just rushing ourselves to get some amount of test, some amount of metrics out there, the bare minimum that will just keep us notified. But that's a learning that we've had where, we need to always fix that by always including the tests and the metrics and what kind of thresholds you're going to be setting for those metrics and alarms during the design stage if you can. And the thinking process should start there.
Interesting.
So there are two ways to look at it. One, after a system goes to production, we want to be notified about everything. That's very important. That's the crucial part.
Of course.
But there's a second part to it. As we develop, we often tend to do some manual testing now and then, right? And then I push the code in. And then someone else in the team comes forward and pushes another code in. Turns out that somehow his code works, my code worked, but then when they integrated, something broke.
Interesting.
So if there were an automated test that always run, that always was running every time I push a code, then that would facilitate catching this bug
because it's significantly easier catching it way earlier in the piece rather than pushing it out to production. You also had a really great discussion about test-driven development and how it's not always appropriate. Take us through that, because that was a fascinating insight you brought.
So that's again subjective, I would say. A lot of people favor test-driven development. The way I look at it is the tests and the functionality go hand in hand. That's
Makes
the
sense.
approach at least I follow for the use cases and the code that I've written so far. The reason I say that is because oftentimes you're not 100% sure what exactly or how exactly you're going to implement the functionality.
That's true. You haven't
Maybe
necessarily
I
thought
implement
about
it as one function, or maybe I split it into 10 functions. So I don't know if I should have specific one unit test covering the whole case and that's it.
Right.
Or maybe I can test the smaller modules, which will return a faster or an exact pinpoint on where the bug is and provide me the ability to spot where the exact issue is. So I kind of prefer, as I implement, I write the test and push both into the code review process together. That's the approach I would like to follow. But there's no one right way and wrong way, whichever suits your need is how I would see it.
But I suppose it's all very much about what's right and understanding what the specific pitfalls are of each. And really, I think that's really great insight. If you're not necessarily sure of what you're going to be doing, you can potentially go down a bit of a blind alley from what you said.
That's true.
That's fascinating, interesting. So when we start thinking about how you can design resilient systems as well, there's obviously going to be some guidance and some design choices that you're making, because obviously we want to be thinking about resilience as early as possible. Some of those when we start thinking about high availability, you spoke about dependencies. Talk us through why dependencies are absolutely critical when it comes to availability.
Sure. So as AWS Health, right, we do have several smaller systems, internal systems, and every company, every team worldwide has these smaller services. So one service probably needs another service to do something, right? And that service probably needs another one. And more often than not, we all develop on the native AWS, so which means that we are developing on the AWS services that are available out there. While many of the services provide high availability, when you actually start designing for a problem that requires a high available solution, the key thing there is to first always consider your dependencies.
Right.
When I talk about dependencies, there are several levels to it. So the first level I would like to speak about is your downstream dependency that you're going to be relying on, is that highly available? Because if that's not highly available,
you're inheriting
clearly,
that availability. You can't do better than that.
Absolutely.
Wow, okay.
You can still work with retries and stuff, but then if it has to meet the latency, then how much longer can you wait for that system to become available and then you actually do the operation, right?
Interesting.
So that's one key way to look at it. The second key way to look at it is you can introduce several services, or you can design one solution in multiple ways.
Okay.
But when you think about highly available systems, it's always better to think about how many minimal services can we pick to attain what we want in the manner we want. But at the same time, we don't lose some functionality.
Right.
So it's very important to keep it simple, but at the same time, make sure all the functionality is met.
It sounds like there's an awful lot that's going on, because ultimately driving that simplicity is key to reducing the complexity when things do go wrong, but then also thinking about how you then reduce that reliance on dependencies, so that, which then also requires a lot of trade-offs to be made as you go through the process. And one of those potentially could be latencies, is, as you said, where you've got to then think about how you can incorporate those trade-offs into your workload. Something else which potentially, a great example which you spoke about, is where developers might choose to think about, say, caching to improve that latency. But then what they're doing is doubling their dependencies, because now you're reliant on a cache as well as the core service that you were using, which now means you've doubled those dependencies. Is it worth that trade-off? So ultimately, I suppose it kind of comes back down to what those specific SLAs are, what those functional requirements are, what those non-functional requirements are as well.
Absolutely. So caching is an interesting example, right? While caching is useful if your application will work with it, but at the same time, the complexity of your application goes up as much as well. So there's more room for errors. It becomes slightly harder to debug. So that's where, the choice between when to go for a cache, when to not go for a cache, when to use this service, and when to probably, avoid that step altogether. And is there any way I can just directly make a one step ahead call to the other service myself, instead of involving this third-party service that I have to go through kind of a approach.
Which is interesting.
Yeah.
And I suppose that reduction in complexity makes so much sense. We often hear Dr. Werner Vogels talking about his quote that everything fails all the time. So build failure in as an operational expectation. And once things do fail, you need to make sure that you've got as simple a process as possible to, again, address that failure. So I think every step that you take, that's an additional dependency which might be operational, but it's also when it comes down to maintenance and addressing operational issues as well, which is fascinating.
Definitely.
Yeah.
The other thing to consider about dependencies, which is quite important, is are those dependencies really available on all the regions that your service is available in?
Interesting, yeah.
That's a very key thing, because oftentimes we end up finishing up the architecture because we have a deadline to finish up the design problem. But at the same time, we go ahead, present it, you get a go ahead, you start implementation, and that's the point when we realize that this dependency is probably not available in a particular region. So you will have to redo some of the design choice during the implementation stage, and that is costly.
So again,
at least
simplicity.
That is still better than after the launch.
Well, I think that's a really good point as well, how you trade off against time, because the last thing you really want to be doing is addressing a change in production as opposed to potentially even delaying. So again, that's that trade-off you make.
Absolutely. So anytime you think of time taken during design, I would say we should invest more time during that time to uncover as many as you can. Think about the different scenarios, think about your customers, what kind of use cases there are, and come up with a solution. Spend as much time during the design collecting the right set of requirements there, more than doing that during the implementation phase or during the after launch phase.
I think that's absolutely critical, and you touched on that earlier as well, because when you are suffering any kind of issue, the last thing you want to be doing is thinking about how to solve a problem if you've had game days which have prepared you for dealing with failover scenarios. You don't want to be formulating a plan during an event. You want to be actioning your plan that you've tested previously through those game days, which I think is also a really great insight. And again, simplicity is key, which I think is great. Something else we spoke of was security. Take us through your perspective on how security impacts resilience, because often you view them as being very important, but not necessarily the same thing. What's your take on that?
So security is, as much as high availability is important, security is as equally important as any of your other functionalities that you would consider for your customers.
And it's our top priority here at AWS, because ultimately we want our customers to trust us, so we need to be very cognizant of security.
Absolutely. Yeah. So where possible, if you're using an IAM role or an IAM policy to allow access for one service to use another service, or one user to use a particular service, and so on, always consider a restrictive permission IAM role that you can give as much as you can. So we deal a lot with IAM roles within our applications, and every time we review the code or every time we push it in, we always make sure that the IAM roles are defined up to only as much as it is required, and nothing beyond.
Well.
Exactly.
Interesting. Which again simplifies the process too, because by reducing that attack surface, it makes a lot more sense as well. You also mentioned validation is absolutely a critical part of security too. Take us through that.
So how much the role restrictiveness is important, so much the validations are important. So naturally, right, when you have a web application, user types in the form fields, and then you realize that one of the form field is a free form text.
Right.
Now, user can enter any kind of data. First and foremost important thing is it could be a PII data.
Yeah.
So we do have restrictions around GDPR and all of that.
Of course,
so how you store this, where you store this becomes key then. So how do you validate that something entered as a free form text is not getting stored in multiple places?
Right.
That's a separate problem altogether. The most important thing about validations, the next important thing I should say about validations is how do you validate the user's input?
Right.
Your system probably accepts a phone number in a certain format, but probably a downstream system where you're going to be storing it accepts it in a different format, which is still okay. But then at the entry point and the exit point, are you receiving the actual data that was sent by the other upstream, or did a man in the middle come and change?
And is it trustworthy all the way through? Which is interesting, because sometimes it's interesting to think about security is all about intrusion protection as well, and also detection. But when I've spoken to some of our security specialists, they also talk about the importance of thinking about something like DDoS, for example, being able to build resilient systems that can withstand a denial of service attack, for example. That's very much a resilience architectural design choice to withstand when your system is under attack to continue operating. And I think this, for me, is a mental model which I think is great to start thinking about, that security and resilience are very much both sides of the same coin almost. You need to be building systems that are resilient to be secure as well for those sorts of use cases as well.
Absolutely. So when you're talking about DDoS attacks, so one of the things that immediately comes to mind when designing for a web application is, if you're using API gateway and stuff, right? The first thing that comes to mind is using the WAF solution that AWS has. Protecting your service by using throttling. You can throttle at different limits, right? You can have API keys to define this user gets throttled for this rate, another user gets throttled for another rate, and so on. So again, it depends on the use case and how much your system can support. But those are the limits that are key to be defined, again, during the early stage of the
building
project.
to those SLAs requirements, which then allows you to build in that resilience through those services.
Yep. And you certainly have to do some amount of penetration testing there to understand whether everything is working as designed.
Trust but verify, I think, is important too. Another interesting thing when we start talking about things like WAF, web application firewalls, etc., is you also mentioned scalability is absolutely key. Understanding what your expected number of users needs to be so that you can actually build your system up to that level, so you've got strong confidence that you can withstand that scale. Take us through that, because that sounds fascinating as well. That isn't something which we normally think about as resilience, but it makes a lot of sense.
Sure. So the natural thing to think of when you're designing a problem, right? Okay, I'm given a design problem. Now I want to design this such that, it is scalable. It lasts for the next 100 years. But in reality, it really depends on how many customers, how many users you have, right? So we've had applications where, we have had a limited set of users using the system, using the service that we've built. And as long as they are happy, we are fine. We don't have to scale it up just because we can do it. But at the same time, there are some services which require extreme scalability. For example, right, in a banking solution, if you're really thinking about, the customer numbers are going to continue growing. Right?
And also depending on what sort of customer you're dealing with, if they're a startup or a scale-up, for example, they need to be building that growth into their architecture.
Absolutely.
Right.
Yes.
Okay.
So understanding the customer use case there is absolutely key, and you need to know that before you start with your design.
Because you can't retrofit that scale in afterwards, because it's going to fundamentally change your entire resilience model.
Sure. You can always design a system where it can get scaled up in the future. Probably you have a plan of action documented somewhere that, hey, this is our current user base. So I'm going with this kind of a solution. In case it goes beyond, then what is my plan of action? It shouldn't turn out to be, all of a sudden there is a significant number of users. Now what do? I have no solutions in place. So like I said, right, during the design phase, if you can spend as much time as you can, rather than launching the product out quickly and customers start using it, and that's the point when you realize, I cannot scale up any further. Now, what do you go and tell the customers, right? Hey, we cannot scale up any further, so we are shutting down this product. Instead, we are coming up with a new architecture. Is a very bad, is a very bad way to go about it. So, spending that time during the design stage is key here, and
So it's something which is a common theme through pretty much everything you've said. Unless you're prepared to do that homework ahead of time, it's probably not going to end too well for you. And I think one of the things you spoke about was observability being absolutely critical as well, and thinking about how you build that observability in from the beginning, as opposed to having to retrofit observability when you are tracking an issue once your system's been released. Walk us through some of those typical scenarios where those are common pitfalls that you've seen some people get into.
Sure. So every time in our design stage, we go through this process called identifying the failure modes that are possible on your service.
Right. Okay.
By identifying that, it gives a clear picture as to should you actually go about spending time on developing a solution to fix the failure mode,
Right.
or is that failure mode okay to live with?
Okay.
It again depends on your application, but
Sure.
understanding when to actually spend time to fix it versus when to maybe have a metric or alarm around
Yeah.
it. Probably it's an edge case, which is highly unlikely to happen. So it again depends on the use case. So, but the understanding is quite important there.
Yeah.
So identifying the failure modes, identifying the right set of metrics that need to be thrown, and having the right set of alarms so that your operational engineer in the team can be notified about when a problem happens, and there should be clear instructions documented on what the operational engineer needs to do
Yeah.
when he hits that issue. There are several AWS services, for example, right, with limits. Every AWS service has quotas and limits.
Yeah.
So
yeah, of course.
one of the things that you can possibly do is, if you feel like you're using a service where there is a limit defined, you're now okay to use this service because you're
Operating
not
well
going to
within
possibly
that.
be you're well within it, and you're not possibly going to be hitting the limit anytime soon. Now, what should you do with this kind of a situation? There is a failure mode, right?
Yeah.
So one of the possible things that you could do in this scenario is have a metric and an alarm that says, hey, I've reached the 50% of this limit.
Let's
So
think about what to
plan.
do.
Yeah.
Figure it out.
If you're going to start planning,
Now's a good time.
now is a good time.
Awesome.
That 50% of the time you still have to go about doing your planning, doing your alternate solution designing.
That's a really fascinating point, because so often we hear anecdotal reports of well, we're getting really close to a limit. Can we raise the limit? And obviously some AWS limits are soft limits put in place to provide additional protection for our customers, and others are actually hard limits because it's fundamental to the way our services are built. And thinking about your approach, I think, is fascinating, because instead of thinking about how you can increase a limit, it's actually thinking about how you can put the right alarms in place to make sure that you never have to get there, and you can then start designing around it. Now, if we think about some of our services that have to scale exponentially, potentially we aren't just deploying a single deployable unit of a given service. We might be deploying several in parallel, for example. So each individual deployable unit stays well within the limits and quotas. So we've got very well-defined behavior. And I love that the way you've described it is, make sure that you've got very clear warning, not as you approach that limit, but well before, because that alarm is saying, please think about something, as opposed to let's get that limit increase, which I don't think is perhaps as helpful as actually designing around that limit and taking that into account as an architectural decision, which I think is fascinating. It's such a sensible way of doing it, but again, comes back to that key message that you've just been reinforcing, is you've got to do that design homework and understanding it, and also thinking about your requirements, because not all workloads will have the same requirements. So we have to build to those, but with the right level of thought.
Absolutely. So you spoke about quotas, right? One of the key things to note there is it doesn't come free. So obviously there is a cost factor associated with it. So how frugal can you be, but at the same time meet your goals?
Yeah, which is critical.
Essentially how it translates.
Which brings us to a really interesting point to think about. Now we've actually covered some of the things you've got to think about. How do you actually put that into action? What are we've outlined these key considerations that you need to take into any kind of workload, but how do you make these trade-offs? Because ultimately it's about trade-off, because nobody's got an infinite amount of resources, time, ability to invest in a workload. There's always going to be those trade-offs. And speaking to partners, I reinforce that security and operational excellence need to be exactly where they need to be for the requirements of that customer workload. And then potentially reliability, cost and performance can be traded off. But ultimately that depends on what the main priorities are for the workloads. So the workloads that you work with, obviously resilience and security are the absolute key North Stars. How does that inform your decision-making process when you start thinking about how you design a new feature into a given product, for example?
Sure. So when you design a problem, it's always better to break it down into smaller milestones. Thereby, we achieve smaller deliverables to the customers, which is our end goal. So customers are happy.
Reducing that time to value
Yes.
to get something out that
Yes.
works. Right.
But in that small amount of time, I am able to put in all the factors that I mentioned before.
Right.
Including availability, including security, including thinking about scalability, observability, and all of it in the smaller milestone, and still have a working solution for the customer.
Right.
So identifying the pain points of the customers and sorting them in the order of the pain that it causes
is your
will help
prioritization.
you prioritize
Wow,
and break
yeah.
it down into smaller milestones. That, to me, is the start of any of the
Yeah.
design problem. The next thing you can consider is, even within that one milestone, you can think about it in several ways, right? First, is there something that we can scope down? But can security be neglected to just because we want this inside scope? Probably not.
Yeah.
So that's where you make the trade-off. However, okay, I'm going ahead and using this service. I know it has these limits, but it is still significantly enough for me, is another wise choice to make, just to circumvent the current situation in hand. That's where the trade-off on, okay, it's okay for me to use this service comes
Right.
into picture. Whereas compromising security is definitely
That's
a
a
no.
no-no.
So
Yeah.
the trade-offs are prioritized in that order, meeting the customer's end goals according to the order of prioritization of their pain points,
Yeah.
and not compromising ever on the high availability or on the security factor. But at the same time, how do you compromise on observability?
Yeah.
When I say compromise on observability, I do believe that we should never compromise on observability.
Yeah.
But what I'm talking about is, maybe you want a nice dashboard kind of a view to understand how your system performs. But you have all the alarms and
Right.
everything in place already to be notified.
Yeah.
Can you compromise by delivering it to the customer and then building the dashboard? Probably yes. Again, it depends on your use case. It
Yeah.
depends on who's going to view the dashboards and things like that.
Again, yeah.
But then with respect to a problem where, this dashboard is only for use within the team,
Maybe it's
you
something
just
you can
review
do
it
later.
weekly and things like that, it should still be okay for you to build that at a later time. So
Yeah.
that's where the ordering or the prioritization of and the trade-offs come into picture.
I think another really great thing you spoke about is when you break things down to smaller milestones, it can help you, because potentially customer needs can change over time as well. And if you were to have a large project with, a single milestone at the end, maybe by the time you've delivered it, that's no longer relevant. Take us through that example.
I've had personal experience myself where I had to build a system, and that involved a big bang feature set.
Yeah.
And then I designed the solution, and it had so many use cases. And when I started presenting it to some of the Amazon engineers, the important thing that came to mind was, hey, if I find it hard to present this whole solution,
Maybe that's a signal somewhere.
it's a signal that
Yeah.
I don't think I can deliver this whole solution in a
Yeah.
big bang fashion.
Okay.
So
Good
that's
insight.
where breaking the things into smaller milestones come into picture. Again, it ties back to the priority order. How do you prioritize based on the customer pain points? And that's how we went about doing that. The core functionality got developed.
Yeah.
We launched it. And then we realized that, okay, the other part, maybe we can solve it in another fashion.
Right.
We don't
Interesting.
need the original the Big Bang feature that we were originally planning. We didn't even need that anymore.
I think that's a fascinating story about where we can actually respond to our customer demand significantly more rapidly as well. Because if you're having to, with that strong prioritization of where customer needs sits, if you're making smaller releases, you can be more mindful of those trade-offs you're making because they're simpler again. You're potentially trading off tens of features rather than hundreds or even thousands. You can then push that value out to customers sooner. And I think this is where our services evolve rapidly because we're inventing and innovating on behalf of our customers every day. And this is why our services have such rapid innovation behind them, because we're actually delivering value incrementally, as you've described, which ultimately allows us to do it safer as well, which I think is great too, because those trade-offs are simpler to make because they're more atomic as opposed to trying to trade off massively complex sets of requirements, which I think this is a great way to lift the lid and explain this is what it looks like underneath. So thanks for sharing that. So one of the key points you also make is when you're measuring trade-offs, you're not just measuring the impact now, you're actually thinking about what the potential impact is going to be for you into the future. Walk us through that scenario, because I think that's fascinating.
Sure. So we've had scenarios where we wanted to build some service. It's a new requirement. And we kind of knew, we started with the design phase, we kind of knew high level on how to go about solving this problem. And then we started spending more and more time focusing on all the other bullet points. And then we were thinking about, okay, so what technology should we use?
Right.
What programming language? And then we turn to the team and look at the team's expertise as well, because we still are working against a deadline, right?
Sure.
I cannot just introduce a new technology all of a sudden. And everyone has this learning curve, which is going to take some time, right? Or out of your actual budgeted time. So
that's true. We forget about that sometimes. Yeah,
that's true.
People have to learn.
Yeah. So when you really think about the technology and things like that, that's when you realize that, okay, team has so much experience with this. Let's go ahead and use the same thing so that we'll be faster and productive soon. And then you go about halfway or even 3/4, and then you realize, okay, maybe I need threads. And you're working on TypeScript under Node.js. And that's when it starts to hit you saying, okay, threads in Node.
This is potentially
I should have
something
thought
which
about
I
it
didn't think
before.
of. Which
Yes.
again comes back to doing doing your homework ahead of time, thinking about needing to think through those designs.
Yep. To be honest, I don't think anyone can come up with the list of all possible
Of course.
problems
It's
that can
paralysis,
happen.
isn't it, when you try to design
Exactly,
that?
yeah. So one of the things that we employ within our teams do have a retro every now and then. Understand, especially at the end of a project, right? Because that's where the most learnings are. And it's part of your agile process. So have a retro, understand what went right, appreciate it, celebrate it, but at the same time understand the areas of
where those learnings come from too.
Yeah, what are the different learnings that I've had? Sometimes it can feel a little bit personal because
We've all been
I did
there.
all the
So that's
hard
good.
work to come up with this design, and in the end it is just these set of improvements. But it's always for the good, because in the next project that you have, you can certainly take these learnings, and those learnings are kind of the key for you to improve.
Right. Yeah, because ultimately I think it's those things that you do right, you celebrate and reinforce that behavior. But where you've got things wrong is where you learn. And I think the only way you can learn from those, sidetracks or potentially things which weren't considerations you built in is actually think about them next time. And part of the challenge of recognizing that those learnings are critical is also recognizing that you can't potentially think about every single alternative in the beginning, because otherwise you'd never get started. And I think sometimes we as engineers want to jump in and solution a little bit too much too early. But it's important to understand where that bias comes from, but also understand where maybe we could do a little bit more thinking up front. But then also temper that with stuff at the back of the project. And I think sometimes that isn't reinforced enough. Hence retros, I think, from my experience, have been absolutely critical, because these are the mistakes you don't want to make again.
Absolutely.
Because ultimately, our customers are looking to buy the virtue of our partner's experience, for example. Technical skill is key, but that experience that you've earned along the way, that provides immense value to customers. I think that's what we'd like to think our AWS customers value as well, which is great.
Absolutely. The other option that you could leverage is have prototypes done, especially on the pieces where you feel a little uncomfortable and you're unsure about. These prototypes can yield good values.
Experimentation, which is great. That's awesome. What I'd love to do is actually start thinking about some of those considerations and consequences of those sorts of decisions. You mentioned at the top of the show the design criteria that you might include for highly resilient, highly available systems. Things such as having, say 3 stacks and making requests in parallel. That was really great. And you mentioned item potency being absolutely critical. Walk us through the importance of that, because I think this is something that's really critical when it comes down to implications of design decisions.
So it again depends on the services that you're going to depend on, and your use cases as well. But the key to any solution, a key to making it highly available is have a failover mechanism always, right?
Yeah.
But at the same time, if your downstream systems are idempotent operations and you could afford to do multiple writes from multiple regions, why not use it? So make the calls in parallel. You're sure to get at least one hit of success. So just take that and proceed. The other calls, even if it fails, we're not going to be bothered about, because, and even if it passes, underneath it's going to be an idempotent operation. So nothing actually changes in that regard. So all you want is for your data to flow through, and it has flown through.
Which is interesting, because idempotency is fantastic. So for our listeners who might not be aware of that, that basically means that you can, correct if I'm wrong, you can make the same call twice without changing the state of whatever you're sending through. So if you have one call or 2, the result is the same.
Yep.
Which is an important consideration, because that now means that you need to think very carefully about the transaction model of your application. Is it, when you start building in those dependencies, such as it can exactly once semantics, where you can only have one call reaching a server, for example, that builds in some complexity. Whereas if you have at least one semantics and idempotent semantics, that now means you can start using this really powerful parallel effect as well, which means that you're always building in that redundancy into every single call, which I think is fantastic.
Absolutely.
But then there's considerations, with every decision, there's always a consideration. Once you've got multiple systems, how do you then sync up the back ends? And this is where I think the consistency model can come in. Take us through that.
So it really depends on the application again there, because not all applications need to be consistent. When you talk about transactions and stuff, certainly, but the highly resilient systems, other than important transaction kind of a business use case, if you really think about, need not be as consistent as possible, right? Even if there is a eventual consistency.
So the data could be out of date as long as you can retrieve it when you need it.
Exactly.
It just might be a little out of date, but you're still getting a response.
Yep. Or probably, I could even do a backfill at a later time kind of a scenario is something, if it's okay with your application, it always need not be consistent.
Yeah.
So consistency is again dependent on the application that you have.
But if you've got multiple stacks, you're going to have to sync that up, but then that consistency model will then creep in. Because unfortunately, the speed of light is finite, and we haven't quite cracked that problem yet, but I'm sure we've got people working on it. There's always going to be time to sync up data somewhere, either in the transaction that you make you waiting longer for all the writes to complete with a quorum, or faster reply, but then subsequent reads might potentially take a little bit of time to come through. So,
Sure. So let's say you're building a chat application, right? Now, I type a message and then the server goes down for some reason. Somewhere, something goes down. But it went to one of your stack and not to the other stack. It just didn't get replicated yet. But then this stack where the data went to had another downstream problem, because of which you cannot use this anymore.
Right. Okay.
Now you have to rely on your other stack, right? Now that doesn't have the data that you need. How important or how critical is it for your application that it is missing this piece of data is what you need to design around. If it's a highly critical piece, then there needs to be design solution in place that supports that kind of a feature.
Yeah.
If it is not, probably wait for the operator or someone, or maybe a cron
synchronize
job
up, yeah.
to do that backfill, and then you can work
But these
on.
are considerations you have to understand ahead of
Definitely.
time, which is great. Something else that we spoke of, you were talking about the value of understanding dependencies on things like your control plane, your data plane. Walk us through that, because I think there can sometimes be some confusion or lack of understanding what we mean by control plane and data plane. What's your perspective there?
I can provide a very simple example to explain this
That'd be
control
great.
plane versus data plane. So anytime we have a feature flag kind of a requirement, let's say, and then we use AWS app config to do that, what we essentially do is we implement the feature flag. You could very easily go into the console. Let's say a customer says, hey, stop this operation immediately, and it's under a feature flag. We just go there, click on the button off, and everything is done.
Okay.
But let's say I couldn't get to the console because that's not on the data plane, right?
Yeah, okay.
Now, what should my design look like there is I should always have some kind of a CLI tool that uses the SDKs to actually go and perform the operation.
Right, okay.
And that is in fact the right way to do about it, because that way you can audit who performed the operation. Because when I go to the console and just click, there's no
Maybe you
record
don't
of
have that
who
record,
did it.
Yeah.
Right? Probably one person in the team did it and then he went on leave. So now what? I don't know what happened exactly, kind of a state. So for auditing purpose as well, it is important. And let's say there are 2 or 3 feature flags. When I go to the console and do it, I could miss and do the other feature toggles as well, or probably do the incorrect one. So when it is a CLI and you have these nice options provided to you, are you sure you want to switch off this particular feature? Yes or no? Kind of a question. It makes it clear, okay, I'm not turning off this feature, I'm only turning off this feature. So you're consciously typing makes it even more better and safe for an operation to be done. And it uses the data plane operation internally. It doesn't use the control plane, which could go down occasionally.
Or there's significantly fewer dependencies, which now means you're more resilient anyway. So which I think, again, it kind of comes back to that simplicity argument. I think that's interesting, which again comes back to dependencies as being one of those key considerations, understanding where your dependencies are and how you match it. This has been a really great discussion, but thinking about looking at the clock, we need to look at wrapping it up. But what are some of those top 3 points that you'd love our partners to think about to really start thinking differently about resilience? What would those three takeaways be, do you think?
From what I've mentioned for the past 30 minutes, the key takeaways that I would like to convey is always understand your customer's pain points and the customer's use cases, and spend as much time in prioritizing and designing the right solution there. Would be my number 1 recommendation. Number 2 is never compromise on security. And number 3 is never, ever compromise on observability. I know it's why I stressed on observability more than security is because security is pretty obvious. Everyone wants secure products, but never has there been such a consideration for observability.
Interesting.
Consider your failures, metrics, alarms. Those are key. Even before your customers come to you saying there is a problem, you should be in a position to know that there is a problem. Have canaries, have end-to-end tests that can help you notify and become alert and aware of the products, of the issues. And that's the key. And that's why I was stressing on the observability more than the security.
No, I think this is great. And certainly these are the things which our partners can leverage, things like well-architected reviews for that, which provides a really great, consistent way to look at every single workload to make sure you're not forgetting these things, which I think is fantastic. Ramya, thank you so much. That, unfortunately, is all we have time for.
Thanks, Richard.
Thanks so much for spending time with us.
Thank you for the opportunity.
And from me, thank you very much. And do please join us for another episode of Partner Buzz in the near future. And please do subscribe so you never miss a show. Thank you very much.